All right, welcome back, fellas, to another day of calculus. So, looking next section, 6.1 antiderivatives. So let's just get right into it. All right, so our objective today is to learn how to find an antiderivative of a function. So, obviously, we want to know, first question, what's an antiderivative? Well, sort of sounds like derivative, right? So it may have something to do with that. So I'll give you the technical definition, and then I'll give you sort of the general colloquial definition. All right, so the antiderivative of a function f is a function whose derivative is f. So basically, instead of taking the derivative now, you're looking for a function that when you take the derivative of it, the derivative will be f. I'll show you what I mean by that in a second. So just a few vocab, right? Finding an antiderivative, we just call that anti-differentiation, okay? Or you could say I anti-differentiated the function at the verb anti-differentiate, okay? So basically now, instead of taking the derivative, what we're trying to do is we're trying to get to the pre-function, let's say. So let's say you have a party, there's an after party, there's a pre-party, and I'm talking about parties where, good people get together and they're, going bowling and roller skating and all those good wholesome things that teenage boys do. So in the past, right, let's say the prom, right? You go to the prom, right? The after prom, that would be like taking the derivative, right? Because you're doing afterwards. But the pre-prom, let's say you get together at somebody's house, you take some pictures, right? That would be the antiderivative. So we're trying to go back in time in some sense. So, example 1, what we're going to do is we're going to find the derivative of the antiderivative of 2x. So, I trust that you already know how to find the derivative of 2x, right? The derivative f prime of x, right, that's the notation we used, is 2. And I'll show you the notation for the antiderivative in a few minutes. Or you could just say 2. So the derivative of 2x is 2. If you can't do that, then you've got to been sleeping the whole time. So now we're looking at the antiderivative. So again, we want to find out what function, when we take the derivative of it, results in 2x. Well, if you just think back a little bit, and you say, what function? Well, how about x squared? Right? If I took the derivative of x squared, the answer would be 2x. So we're correct, and we found the correct antiderivative. So the antiderivative of 2x is x squared. However, how do we not know? It could be x squared plus 1, or it could be x squared plus 2, or x squared plus 3. How do we know? Well, really, we don't know, because remember, the derivative of 1, 2, and 3 is 0. So it could have been x squared plus 10, plus 20, plus 30, plus 1, plus 2, plus 3, plus 4. But since we don't know which number, right, or it could have just been x squared, right? So since we don't know which number, or if there were any, we're hanging out with x squared before we took the derivative of it, we're going to put plus c. The reason we put plus c is that c represents a constant, okay? So c could be any number. Now again, if we took the derivative of x squared plus c, we would get 2x plus 0, or just 2x, right? Because the derivative of c, a constant, is 0. So we know we got the right answer for the antiderivative, because if we take the derivative of the antiderivative, we end up with what we started with, and what we started with was 2x. Okay, let's keep going. All right, number 2, find the derivative and the antiderivative of 4x cubed. Well, I trust you know the derivative. It's going to be 12x squared, right? And remember, there was a formula for finding the derivative using the power rule. So we also have a rule for integration finding the antiderivative. And I'll show you that in a few minutes. So if you're kind of lost, don't worry. I'm just trying to get to the point. Maybe you think I'm not getting to the point fast enough. But anyways. All right. So if you're trying to find the antiderivative, again, we want to find what function, when we take the derivative, would give us 4x cubed. Well, hey, how about x to the fourth? Right? So the derivative of x to the fourth, right, f prime of x equals 4x cubed. So we picked the right one. So the antiderivative is x to the fourth, but again, it could have been x to the fourth plus 1, plus 2, plus 3, plus 4. So we don't know, so we're just going to say plus c. So this is our antiderivative. And that's really what we're focused on today. Okay, next one. Find the derivative and antiderivative of cosine of x. So derivative of cosine of x is negative sine of x. Now, with the trig functions, which we'll focus on more a little bit later, the cosine it doesn't follow the same rules, right? The power rule, these were mostly ones that you had to remember, right, when we took the derivative. So which function, when we take the derivative of it, gives us the cosine of x? Well, I think that's easy answer, right? That's going to be the sine of x. So the derivative of the sine of x is the cosine of x. And that makes it the antiderivative. Okay? All right, last one. A little bit more difficult. Find the derivative and antiderivative of 7x to the 8th plus 2. 7x to the 8th. That should say 6th. Okay. And that should say 6th. Okay, so again, we're trying to find the derivative. So we get 42x to the 5th. Okay, derivative of 2 is bye-bye, nothing. So now again, we want to find the antiderivative. Well, what function would be the derivative, would give us the derivative 7x to the 6th? Well, that would be x to the 7th. Now, what function gives us the derivative of just 2? Well, that would be 2x, right? So again, we can check this by taking the derivative. The derivative of x to the 7th is 7x to the 6th. Derivative of 2x is 2. So we get 7x to the 6th plus 2. That's what we started with. So we're good. Now, remember, we just need to add a plus c, because again, we don't know if the starting function was x to the 7th plus 2x plus 4, x to the 7th plus 2x plus 3, x to the 7th plus 2x plus pi, right? Could have been any of those. We don't know, so that's why we put c, okay? Now, if you're wondering, Ms. Ramsey, could we ever get a number for c? Well, yes, we could get a number for c. You know, it's possible if you set up some conditions and situations. Yes, you could eventually find it depending on the problem. But right now we're just focused on the general case, which would involve us adding c. So again, if you're totally lost right now, don't worry. I have a rule for you that will make this hopefully a little clearer. Okay, so if you want a formula to find the antiderivative, I'll give you one. I supply. So the formula to find the antiderivative of a function can be used. You can use this formula. So I'm just going to go through what this means. This means find the antiderivative, or we would say the integral, okay, of a function, a polynomial function. Dx just means with respect to x. It means you're taking the derivative of x and not some other variable, okay? So the antiderivative, or the integral of x to the n dx, is equal to what? Well, it's equal to x when we add 1 to its exponent, when we divide by its exponent plus 1, and then we add the plus c on the end, okay? So this is the formula. Now, you may be wondering, what is this used for? Well, what we'll find out later is that finding the antiderivative, or what we call the integral, right, has to do with finding the area under a curve, okay, which can be helpful for many things. As you can imagine, if you take this to 3D, right, you can find the area of, the volume of some object in 3 dimensions, okay, which computer-wise, that can have its advantages. And we'll talk about that later, about where that can be applied. You can do some crazy stuff with this, right? You can do statistics with integral calculus. There's all kind of different paths. So if you don't take my word for it, go Google it and you can find out for yourself. Okay. So again, that's a formula. Let's take a look at how we can apply the formula to some examples. So, example 1, find the antiderivative of x to the 5th using the rule above. So, again, all we're going to do, the antiderivative is found by taking what we started with, x to the 5th, adding 1, dividing by the exponent 5 plus 1, and then adding a plus c at the end, okay? And then you're just going to clean this up and call it x to the 6th over 6 plus c, okay? So x to the 6th over 6 plus c is the antiderivative of x to the 5th. So it's like the pre-derivative, okay? The derivative of x to the 5th is 5x to the 4th, right? But we're trying to get the pre-derivative, right? The pre-pom, right? So we're trying to get what the function was before it was what it was, okay? So in any case, now to convince yourself that I'm correct, again, you can take the derivative of this function. We get 6x to the 5th over 6, which equals x to the 5th. So, since when I take the derivative of the antiderivative, I get what I started with, which was this, I know I've done it correctly, okay? All right, example 2, find the antiderivative of 2x to the 6th plus 3x minus 4. So yes, there doesn't always have to be one term in these, right? You could have 2, 3, 4, 5, 6 terms, right, for polynomials. Okay, but if that's the case, then you will just apply the rule to each individual term of the polynomial. So again, now we have 2x to the 6th, so we're going to apply the rule. 2x to the 6th, we're going to add 1. We're going to divide by 6 plus 1, okay, plus 3x to the 1, right? That's really a 1 there. We're going to add 1 and divide by 1 plus 1 minus 4. So this is really minus 4x to the 0, right, plus 1 over 0 plus 1, right? Because any constant is literally just the constant times x to the 0 power. Now again, if we want to clean this up, simplify, we get 2x to the 7th over 7 plus 3x squared over 2 minus 4x over 1, which is just 4x. So the antiderivative of 2x to the 6th plus 3x minus 4 is equal to what I wrote in the box. Take the derivative of what I wrote in the box to convince yourself that I am correct. Okay, let's have another one. So, now again, I didn't really stress this too much, I don't think. Again, this symbol means take the antiderivative, right? Find the antiderivative, find the integral, okay? All right, so we're going to find the antiderivative, find the integral of x to the 4th minus x cubed plus x squared dx. So again, the dx just means we're taking the derivative with respect to x. So what that really means is, if you want to get real deep into it, right? If we added an a here, a would be treated like a constant, and x would be the only thing that is treated like a variable. So you'd only apply the power rule to the variable. You wouldn't apply the power rule to the constant a. It would just hang out like a number, 6, 5, 4, 3, 2, 1. All right, so let's take the antiderivative. So again, I'm just going to use that rule up here. Once you get used to using the rule, it'll be like second nature to you. But I'm going to write it out, and I suggest you write it out as well. in long form so you don't make a mistake. You know, you don't want laziness to be the reason why you don't do well, right? Okay, so again, take the derivative, find the antiderivative of x to the fourth. So again, I'm going to add 1 x to the fourth plus 1. I'm going to add 1 to the exponent and divide by the exponent plus 1. Do the same thing with x cubed plus 1 divided by the exponent plus 1. Plus x squared, add 1 to the exponent, and divide by the exponent plus 1. So now I get x to the fifth plus 5, x to the fifth over 5, minus x to the fourth over 4, plus x to the third over 3, plus c. Can't forget our old buddy, plus c. Okay? So if you can tell, this is going to go a lot like the derivatives chapter where you have to remember the rules to play the game. Okay? Don't hate the player, hate the game. All right? Okay, last one. Now we have negative exponents, so don't freak out on me, right? So basically what you just want to keep doing, the same thing that we're doing. Don't convert them to positive exponents until the very end of the problem, okay? Just like we did with derivatives, okay? So remember, the reason that we use negative exponents when we find the antiderivative or take the derivative is because we can apply the power rule. In this case, we can use the rule up here for finding the antiderivative, okay? So we're going to use that rule, right? This symbol tells us to find the antiderivative, right? Take the integral is another way to say that. So again, we're going to do the same thing. So we're going to do 3x to the negative 2 plus 1 over negative 2 plus 1 minus 4x to the negative 3 plus 1 over negative 3 plus 1 plus c. And again, you just want to clean this up. We're going to get 3x to the negative 1 over negative 1 minus 4x to the negative 2 over negative 2 plus c. So I'm going to get negative 3 over x plus 2 over x squared plus c. Okay? If you want to check your answer for that, I would definitely recommend doing it while you have the negative exponents. But again, we want our final answer to be in positive exponents, okay? Because eventually what we're going to do is we're going to plug in numbers for x, okay? Just like we did in the derivative section. So one last comment, right? Again, if you want to check to see if your antiderivative is right, take the derivative of the antiderivative, and that should give you the function that you started with, namely the function that they asked you to find the antiderivative of, okay? All right, well, hope you guys have a wonderful day. I'll see you soon, God willing. Have a blessed day.